Today's discussion subject is our transformer sizing. When we select proper transformer for a power system, we follow the certain points. First you determine the connected load. What is the connected load? The connected load is the sum of all the individual loads such as lighting, motors and HVAC. Other loads there may be. Then taking the connected load, then we apply this demand factor to find out the maximum demand. So the maximum demand, we take the maximum demand is connected load into demand factor. To find the maximum demand, we take the certain specific value of the demand factor. For residential load, we take 0.4 to 0.6. For commercial load, we take 0.6 to 0.8. And for industrial load, the value of the demand factor is taken 0.7 to 0.9. The next point is your consideration of diversity factor. If your transformer is connected to multiple feeders, then you have to take another factor that is called diversity factor. Due to that diversity factor, we take the diversified load. To calculate the diversified load, we take the sum of individual demands, maximum demands, divided by the diversity factor. Usually, the value of the diversity factor is taken as greater than 1. Generally, it ranges from 1.1 to 2.0, and specifically it is 1.2 to 1.3 for residential areas, and 1.5 to 2.0 for mixed commercial and lighting loads, and 1.4 for industrial loads. The next point is your conversion of that kilowatt load on the transformer into kVA load. The transformer is rated in kVA. We have to calculate what is the kVA load on the transformer. The kVA load is the transformer calculated by kilowatt divided by power factor. The power factor for industrial load is taken as 0.8 to 0.9, and for commercial load, it has been taken 0.9. After that, we take some additional load margin for future expansion. That is 20 to 30% above the normal load. So the total kVA will be calculated kVA into 1.2 to 1.3 times the calculated kVA. That is the total kVA. After that, the total kVA we match with the list of given list of standard transformers. During the choice of transformer, whether we require the distribution purpose or we will use the power transformer or dry type transformer, accordingly we choose, and accordingly there are standards. The distribution transformer, these are the standards. In the voltage class, 11 kV by 433, 22 kV by 433 volt, and 33 kV by 433 volt. 3-phase ONAN cooled, outdoor, indoor, oil immersed with vector group DYN1, winding materials aluminum or copper for low rating with efficiency level 1 and 2 with following capacities. You have to choose this. If your transformer will be power transformer, we can choose the transformer for higher rating list from higher rated transformers. This may be your 3.15 MVA, 5 MVA, 80 MVA or above, or with the voltage class 33 kV by 11 kV or higher voltage classes. We may choose, if we require the dry type transformer, we can choose from this. From direct drive transformer, the design is your VPI or cast iron, indoor or outdoor type within following capacities. You can choose from the list of given standard transformer. Then after that, we have to check some additional conditions, additional points. That is whether the transformer is at what voltage level, it is at LT or ST voltage level. And cooling type, whether it is ONN or ONF, it is sufficient according to the rating of the transformer. You have to take the design factor. Loading limit should be 70 to 80% with the for luck limit. If the transformer is loaded 70 to 80% of the normal rated load, then its life will be long life. Similarly, ambient temperature should be within this permissible limit, that is 40 degree centigrade maximum or 30 degree centigrade on 24-hour average limit. If it is operated at 40 degree centigrade, the transformer should be derated. And the oil temperature should be maximum 90 degree centigrade and winding temperature should be maximum 120 degree centigrade and should be maintained to avoid the insulation breakdown. Otherwise, there is a chance of insulation breakdown. Similarly, we'll consider the motor starting. When the load is industrial load, several motors are connected, large motors are connected to the power system. Then it draws, normally it draws 5 to 7 times its full load current. And if it be started, then there will be voltage dip, and that voltage dip should not be should be always less than 10 to 15%, not more than that. Lastly, we have to check the short circuit capacity of the transformer, whether it will stand the short circuit capacity according to the calculation formula. That is, fault level is kVA into 100 divided by percentage impedance. The transformer impedance is taken as 5 to 10%. So all these 9 factors are very essential during the selection of transformer sizing. Thank you.